So yesterday's lesson was posted on YouTube after school, and I added in on the Google Classroom some practice problems. I think there were either 6 or 8. After today, depending on your level of comfort, go home and practice those problems. Okay, if you're still really struggling, you can rewatch the lesson, you can watch today's lesson, and then you can do some of those. So these are the systems that we're going to work with today. What's the main difference between that system and the system that we looked at yesterday and even at the beginning of class? Take a look at both equations. What do you notice is different?
Constants have variables. For the top, for the one on the top, it has.
Our variables have, what's that?
Constants.
Coefficients, right? Don't get the words, you add the words a little mixed up. Those, the variables in the top equation have coefficients. Okay, what else do we notice? Okay, so none of the equations are already set up to have one of the variables by itself. Does it always have to be y by itself?
No.
Could I substitute for x?
No.
Could I?
Yeah.
Why not?
In any? Sure, yeah. But notice that these equations, very different than back here. If you look back to the warm-up, we already had a value for y, so it was a little straightforward when we were substituting in. Do we have something alone right now?
No.
So do I know what to substitute? No. So I need to do something a little bit different. How can we figure out which variable we want to substitute?
Like get it.
We'll get the y by itself.
Get it by.
What would be the easiest process?
To get the y by itself.
I feel like 3y plus 4.
Is there any variable that we can get alone? So let's identify what the variables are. Either this y, this x, or this y. Is there any variable that we could somewhat easily isolate?
Yeah. The y.
Yeah.
Which y?
The
The
top
one.
one.
Which one?
The bottom one.
The bottom one. Is it, what would I have to do to get this y by itself? I can do my inverse operation. So neither equation here is solved for a variable. So we need to do something to find the value of a variable because I don't know what to substitute yet. I need to find something to substitute. So you don't have to write this down, but this is just some assistance, some help. If the variable here, and you all looked at it and you pretty much saw that the y would have been easiest to isolate because there's not a coefficient, right, or a visible coefficient. There is a coefficient. The coefficient is 1. But if we had a coefficient of 1 or -1, think about what would happen to get this variable alone. To get y alone, I can work my inverse operations. If I wanted to get any other variable alone, what would the last operation be to get it by itself? To get rid of that coefficient. I have to divide. What's the problem if I start dividing everything? I could do it, but what might happen to my equations? Might get not necessarily unbalanced, but what happens if I divide various numbers? What might I end up having to work with? Yeah, I might have to start working with fractions. Now you could do that if you really wanted to isolate this x right here. You could. You can get it by itself. We did that in Unit 1. We worked with literal equations. You may not want to do that. You may not want to work with fractions. The nice thing about this variable here, this y, I won't end up with a fraction. I can just reword this or rewrite this equation to get y by itself. So here I still have 3y plus 4x equals 14. What would happen if I rewrote that bottom equation to get y by itself? What would I have to do to get y alone?
Add 2x.
I can add 2x so that I get rid of this. What else do I need to do? I do the same thing to the other side. Does this just become -x? Yeah, my equation here is just 2x minus 3 or -3 plus 2x. Why can't I combine those? Because they're not like terms. So now, did I change the core of this equation? Did I change the value? Is it still balanced? Yeah, it's still balanced because I added 2x to both sides. What's the difference, though, between this equation in terms of solving my system and this equation in terms of solving my system. Why is this more helpful right now? So now I know, yes, I already know what y equals, so I can replace it and I can solve. So now what would you substitute? I'm gonna replace a y. What am I replacing any of the y's with? I'm gonna replace the y's with 2x minus 3. So any of the y's I'm gonna replace. How can I rewrite that equation? So write down what the equation would be if I substituted in the 2x minus 3 for y. So in this equation, what are you replacing? Y, and only y. So what do you do with the 3?
3 parentheses.
Why do I still need to represent the 3?
Because it's part of your equation.
It is absolutely part of the equation because in that top equation, how many y's do I have? I have 3. So no matter what I replace it with, I have 3 of them. How would I solve that?
You do 3 times 2x is
3 times 2x?
and then 3 times 3.
And 3 times, okay. So what do I get when I multiply that?
6x minus 9 plus 4x equals 43. And then you gotta combine your like terms.
To solve, I can combine my like terms. Right, this is a great example to have written down. What if I combine my like terms? What do I have? Now what?
Now you're gonna
Add 9.
add 9.
So 10x equals
20.
23.
21.
23.
Really? Oh yeah. Sorry.
Okay. So what's x?
Uh-oh.
X is 2.3. Is it possible?
Oh, I did something wrong.
It's okay. Take a look at where you went wrong. If you went wrong with the calculation, it's not all bad. The goal right now, you're being assessed on if you can substitute. As we progress forward, we want to really make sure those calculations are correct. But right now, the goal is, do you understand that you can replace something?
Yeah.
Can x be 2.3?
When you can't.
Well,
Now, did we solve it correctly?
Yeah.
Yeah. So is x 2.3? Yeah. Okay, can that be the solution to our system?
No.
What else do I have to do to finish solving?
You have to.
I would have to find y. Can I do that? Sure. I can do what with x?
Plug in.
I can plug it in. Which equation might be
Y
easier to do that?
equals.
Okay, if I rewrite this bottom now, I don't have 2 unknowns, I only have 1. When I calculate, what does y become? A little crazy because we have decimals, but how would we check that?
You plug in.
So if I think that x is 2.3 and y is 1.6, where could I substitute just to check? I already know it's working in the bottom equation because I substituted it at 2.3 and I found 1.6. Let's try it here. If I multiply 3 times 1.6 and I add it to 4 times 2.3, does that add up to 14? Try that really quick. 3 times 1.6 and add 4 times 2.3.
Yeah.
What is 3 times 1.6? What is it? 4.8. Okay, 4.8. And what's 4 times 2.3?
8.
Does 4.8 plus 9.2 equal 14? Yeah, it does, so that works. So it's okay if your system gives you a decimal or a fraction. It's, if you wanted to keep 23 over 10, if you wanted to keep that as a fraction, you still would have ended up with the same answer. You would have ended up with y is 1.6 and x is 2.3. You might have ended up like 2 and 1/3 and 1 and 6/10 or 3/5 if you kept it in fraction format, but either way, your answer is still correct here. So we actually answered a lot of these questions, so I'm going to slide over because we checked. So now let's take a look here.
Whoa.
I want you to figure something out for me. I went to the movies. I love the movies. I go all the time. And I bought some stuff. There were no soda containers, so these mugs represent like soda. So I know a few things. I know that I bought 4 drinks and 2 things of popcorn, and I spent, that's $28. There's the $20 bill, and then a 5, and then 3 singles. So I spent $28. Okay. I also know that 1 popcorn is the same price as 3 drinks and $4. So 3 drinks and $4 extra dollars. Can you find the cost of 1 popcorn?
I've done this. All that game that she has played.
Can I figure out?
Like, can we talk?
You can absolutely talk about it.
Wait, so the top one is $4?
So the popcorn is the same as 3 drinks plus $4 extra dollars. And then the 4 drinks and the 2 popcorns, because I love popcorn, equal $28. So could you figure out how much? 3 drinks and $4. Yeah, these are singles up here. Those are dollar bills. And then this is a 20, a 5, a 1, a 1, a 1, so that's 28.
And then wow. You got it. That's you got it.
Wait, were those the real prices or not?
You're welcome.
So what are we trying to figure out?
The cost of the popcorn. How much did it cost?
That's easy.
I got it. Oh, got it. Oh wait, no, I didn't get it.
Right here.
I know, I just did it. I just looked at it and I got it.
Is there a system that you can, is there a strategy that you can use?
I just figured out how many.
Wait, you need to go.
It's right. Yeah.
Oh, wait, I got it one. I was like, I got 2 of them.
Yeah, I'm happy. I did.
Guys, it's boom. Oh, what's the hell? You know what S is?
What? That popcorn mad expensive.
No, it's more expensive at the theater.
Wait, did you actually go to the movie theater?
Say again?
Did you actually go to the movie theater?
I went to the movie a little while. I went 2 weeks ago.
Which movie did you watch?
Justice.
I want to watch. There's this new one. It's perfect. It's never really going to watch now.
So what is the, if we're having any difficulty here, where's the difficulty? If we're trying to find the cost of the popcorn,
Yes, I got
Be careful. Very.
Yeah. No, didn't you guys see me? I was just staring and then I got
So what are we? What is the issue in the beginning? So like when I'm looking at this problem, why can't I just say popcorn was this much money, game over, I'm done?
Because it's a math.
Because it's objects, so it's like I need the numbers.
Okay, so some of you might not be used to seeing something in this format, right? This is a little bit, I know it's pictures, but it's a little bit more real world that you're trying to actually find the value of some real thing instead of just like X, it's something.
Which is
Right.
why I had to.
But in addition to that, why is it hard to find that unknown value of the popcorn based on just the information that you're given?
Because to find like one value of one variable, you need to find the value of another variable, so that can help.
Yeah, what else? What don't we know here?
We don't know how much.
We don't know how much the drinks are, right? If I knew, like, hey, a drink's $1, I could easily find out the cost of the popcorn, but I don't know the price of the drinks either. So that's a little bit of a problem. Now, I would love to somehow represent this situation in either all popcorn or all drinks, because then I know I can narrow down value, right? Is there anything I could do? Is there enough information here to make some moves? To figure out, well, I know this is this, so I can reason.
Yes.
What could I reason? Just based on the picture.
For the top one, it could be y equals 3x plus 4.
If you wanted to write an equation, you could. Y equals 3x plus 4.
Oh.
Right. So there, y would be your popcorn, and x would be your drink. Now, I would recommend, as we start to do some real-world scenarios, to make a note of what variable is what. Because if you'll notice when we start practicing systems, they can get kind of lengthy. And if all of a sudden you did all of that work and you're like, x is 6. Like, but wait, is x the popcorn or is x the soda? That can mess the whole thing up. And especially when we start to get into some word problems, it's okay to not use x and y.
Yeah.
If you're talking about, if you're talking about popcorn, it could be a P. If you're talking about drinks, it could be a D. That's just another way to keep yourself organized. So you could write an equation. Is there anything visually that I know is the same as something else?
Yes.
What?
Oh, you could do the other equation.
I can write the other equation, which is what?
It's 4x plus 2y, which equals 28.
For those of you who solved, what'd you do?
And then
I looked at it and I was like, oh snap. And I
So did you solve it? Or did you just stop at saying, oh snap?
no, I
So where can we go from here? And the reason I use the visual, some of you don't want to use the equation right now and you need to see it in a different way. The visual might make a little bit more sense.
And then you gotta let go. Any place you see y, put 3x plus 4.
Okay, so anyway, if you're talking about the equation, anywhere you see a y, you can put in a 3x plus 4. But in the picture, what can I do? Anywhere I see a...
You add the x.
So Sarai just used the idea of substitution. She said, anywhere I see a y, I can put in a 3x plus 4 because that top equation tells me that y equals 3x plus 4. What about the picture? What if I didn't want to use an equation? Can I get rid of something? Can I replace something?
I
3 is a 3 plus a popcorn.
So I can get rid of one of the popcorns. And what would I put in its place?
3 drinks.
3 drinks. And what else?
Oh, you wanted it.
And $4. Alright, so $4. What else could I replace?
the $4 means nothing. Right?
Can I figure it out now?
Yeah. Yeah.
Is there anything
Yeah.
else I can replace?
No.
So now the problem down here is I still have drinks, dollars, and popcorn. I still don't, I
Put
know.
the dollars.
Take away $4
Why?
because
Eventually I will solve. But what else do I need to replace?
Last
The other popcorn. Right? Because I didn't have one popcorn down here, I had 2. So what else do I need to put there in its place?
$1 more.
$4 more dollars,
3 more cups.
3 more cups. Those are bad cups. But for those of you that solved the system using the equation, you replace the y 3x plus 4, but you still had the 2 because there were 2 of them.
I substituted a number in.
So now, whether you're going visual or not, if I have, what do I really have here?
2
9
popcorn.
cups.
I have 4, 5, 6, 7, 8, 9, 10 cups. And how much extra money? $8, and that equals
28. The same
28. Same thing, if you distribute it here,
Now I get
4x plus 6x plus 8. Now, I hear you over there, I can subtract 8, so 10x is 20. So what's x?
2.
And what does x represent?
The popcorn.
Does it?
The drinks.
We wrote it right at the top,
Oh, the couple.
the drinks. So how much is each drink?
$2.
If each drink is $2, how much is my popcorn?
10.
10, because this would
Oh,
be
you're talking
$2,
about-
$2, $2. So that's
You getting
6
yourself?
plus 7, 8, 9, 10. The visual is there just to show you that it's legitimately just replacing the variable with this entire value. I mean, I drew it in just to make it more time efficient. But that's the idea of substitution. So we're going to try one. Now the one that you see, you might have to do a little bit of manipulation here. How can we find the solution to this system? I'm actually going to pause the recording.